I'm sure this is transposing itself onto the waveform, but before we do anything, let's take a look and see if that's the case. Yeah, sure enough, it's modulating. You see that? So let's raise the volume just a hair. Well, that was me. That's loose cable. Let's take a look. You ready? Yeah, there you go. It's modulating. That's no good. So I imagine the good news is the whole preamp side of the circuit is just fine. The bad news is it's the finals. The good news is we just found out why this sawtooth is causing it to modulate and exacerbate the problem. You can see it just gets worse the more power you give it. And we end up with this funky looking waveform here. So let's find out why this is the case. There isn't that much DC making its way to this side of the amplifier. So we'll see what's going on. Yeah, well, this is a problem. So you got the 130 volts plate voltage here to pin 7 is actually voltage dropped because it's coming through the coil here from this switch. It was in fact originally that 138, you know, back in the day, that old voltage, right? Coil in fact acts as sort of a filter, but if you look here, it's only got the benefit of that 50 microfarad capacitor. It's not going through that second stage here of filtering. So that's the dirty one we looked at before that we had moved off of because we didn't need to deal with it anymore. But this one is still dealing with it. So we have to address this issue here and see why this is still so funky. So you know everything about this device, as mentioned in previous videos. You got your power transformer here, the 12AX7, the beam power tube. Everything is just in such close proximity. Heathkit made another model that was like 4 times the size to allow for separation, but it's not as compact. It's not as fun to work with to do this. To that end, you have to deal with a lot of power supply noise issues. And as a signal tracer, it really didn't matter. But what I've done is to deal with this issue, I have gone for the big guns and said I'm going to put in a basically do what I was going to do before I had to abandon that effort because I no longer needed to. Put in a capacitor, but I didn't go with this 80. I went with a 200, and I'm going to show you the effect that it had. I'm going to turn up this, and it won't take much, right? I'm going to dial this in here, right? And this is what it looks like. And there's still a little noise. There's a little, you know, noise being modulated onto this. But to truly understand the effect that this capacitor has, I need only remove the capacitor from circuit, which I'm going to do now. And that's what it looks like without the capacitor in place. I'll put it back in. And it cleans right up. So if I lower that back down, right, and then take the capacitor out of circuit, you can see that slant there. And if I take that slant and then I go and adjust so we can see what the noise actually looks like, the little gremlin there. There's the noise before filtering, which we have none of really in that first section, that little 50. Yeah, we do. It's fair to say we do. But here we go. You ready? And there it is with the filtering added. So much needed improvement, but there's still all sorts of, you could see there's all sorts of harmonics aside from the filtering that's being done. There are other things that are in here. The capacitor has removed that sawtooth that we see from the AC. That AC sawtooth is gone. Maybe that there's like a tiniest of artifact. There's just a tiny artifact right there. There are other things floating around in this unit that we can see here that extend beyond that. They're feeding back, and adding a filter cap to the diode is not going to pull those out, and that is going to be a characteristic of this amplifier. Question then becomes, given this, you know, how is this now going to perform? And I'd say with the new filter in, I think it's going to perform a lot better. It's not breaking up anymore at low volume. So I think it's pretty good. I think it's time to hook a guitar and see what that does. Something else occurred to me. that might be worth looking into at this time. And it doesn't have anything to do with the electronics itself. We've listened to the radio going through here relatively loud, and we've also listened to now, after this correction has been made with this large capacitor cleaning up a lot of that distortion, we've listened to a single sine wave go through here, and it gets very loud without breaking up. But when we have several sine waves, we're starting to hear this sound rumbling through here. And it begs the question, could this be a physical issue? Could this be, in fact, the speaker itself? There's an easy way to determine this. I have up here, way up here, this black speaker that I use for testing. This is an 8 ohm speaker, much larger. It's not wonderful, but it's definitely a big improvement over this one. And what's important is it's not too big. So this amplifier could drive that speaker. So what I'm going to do is I'm going to disconnect this speaker. I'm going to quickly wire in that speaker up there. And we're going to see and make sure that the amp is in fact not distorting at all. And it's just a limitation of that little speaker. We could probably talk about replacing it with a higher quality speaker in here, or providing an option where if you're using the internal speaker, we have a resistor that shunts that signal to keep the volume lower, and then have a switch that allows for an external speaker which allows for higher volumes. We'll see what we're going to do. Let's see what's going on first. The good news or bad news, depending on how you look at it, is it's not really the speaker. The 12AX7 is just really driving this beam power tube way beyond its capability if I run the volume at full tilt. So I found just an area right here before it breaks up. So I'm just going to give it a strum. You ready? And it's not breaking up. And here's the tone knob. I'll run the tone knob back and forth. Just tone all the way down. Tone all the way up. And back to the middle. And if I make it a little louder... Actually, it's still good there. Right there, it starts to break up. So, ideally, what I could do is using this bigger speaker as a reference. The best point without modifying the sound of this stage is to look right here where I put this question mark and dial back this resistor here to ground. This is the feed point to the beam power tube. Remember that this has all been modified in support of the Gibson, but we still need to meet this point right over here. And also, I haven't modified that, but that's okay right now. Meet this feed point and say, we're going to tap off some of that and lower the input signal coming into here and see if that can help out a bit. I realize this all looks like a mess right now with wires coming out of this thing from every direction. But we are back on the original speaker, okay? That 330K resistor to ground right over here that meets the signal before it goes into the grid of the beam power tube has now been adjusted. It now sees a 12K resistor going across that 330 in parallel. That's how I did the testing anyway. I have a whole bunch of resistors like this that I have measured, and I just clamped onto them till I found one that at around full volume just starts to break up when you just strum the guitar hard, right? And then I once I homed in on it, I was able to work with the tone knob there to just find the perfect mixture. So much so that I wanted to, turn this thing around so we could get the speaker sort of facing forward for this. And I don't want to bring it too close or we're going to start to hear my cell phone in it. So you turn it in any direction while the case is off on this thing and it'll pick up everything. It's not shielded. Be that as it may, let's take a look. You ready? The guitar's in a stand, by the way. I'm not holding the guitar, so this is not easy to do. And what we're going for here is distortion. You'll notice that the volume is at 80%. We're at the top end of this. where it's just starting to break up. And that's why I've set the volume here, because this is where I want it to start breaking up. You wouldn't run it at full tilt, but just over here, as my wife had pointed out earlier, you could hear a vibrato in this. Got a wah, 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 wah. Very nice. The characteristic of this amplifier. And not only that, I'm going to have to move the camera to show this, but you can see that is displayed in the Magic Eye. That oscillation is shown here. Very cool. Again, the way that this is set up, if you're going to bring these knobs on full tilt in any direction, you're going to get dramatic results, and that's understood. Even on the Gibson, that was understood. The same thing applies here. Full treble, you're going to get some breaking up. Full bass, you're going to get fully muffled. You know, you bring it right around the middle. And this is as far as the volume knob goes. And when I put this resistors in, I did it so, I mean, you can run it past. You could run it to 11, basically. You shouldn't, but the ability is there. So there it is. That's... Ideally, I see it at about 78. Is where it breaks up nicely. That's where the max headroom is, and then it starts to fall apart. I have an idea to make some further improvements. Before I get started, though, I want to make some checks here. We know that this value here is 124. It was a rise of 10, okay? And this one here shows 130, but I've never measured it, right? We could only imagine that it's significantly higher. And this one was coming down from this common one. It's feeding the Magic Eye tube. It's also the one that didn't have any filtration. This one, if it's too high, I'll tell you right now, all that I need to do is get the correct voltage dropping resistor before pin 4 to bring this back into specification, and this should be good. So let's get started. So what I'm seeing here is this value 130 is what it used to be seeing. Now is seeing 160. It's way too high, and this is coming off of through that coil directly off of the diode. Looking at the increased voltages from 114 to 137, we could see that increased the values on these. These were already measured before. They should be no great surprise, but that's just fine. No problems there. So we don't have to make any adjustment for the 12AX7, nor did I plan to. But I just took some measurements here. The voltage here is 166. Worth pointing out, that 166, or 168, sorry, is also coming directly here. So in order to more correctly bring these voltages back into specification, I've opted to drop them appropriately with a voltage dropping resistor. And what I have found is with everything in line under the correct load, 120 volts, and that's what I'm working from, modern voltages. So I have that distinct advantage here now, is I have this tap over here, you can see, disconnected, and coming off of the rectifier is going to be a 1.6K ohm resistor, and that 1.6K ohm resistor is going to provide for what I'm showing here to be up top. It come out to like 131 volts. So we're going to put that in right now permanently, and we're going to call that one solved and move it on to the next one. I also don't want to wrap this red wire all the way around the entire device and through to meet that connection. So what I'm going to do really quickly is I'm just going to tie another resistor onto here and lower the voltage on that too. That's just going to be a simple way to connect this. It may not be the best way, but it is the easiest. Added a 68k ohm resistor right here, brought this voltage down to just around 130, which is going to be just fine for this. Couple volts lower than spec, but I don't mind getting a couple more years of life out of this magic eye tube. By fixing all the voltage issues and being able to lower the distortion, I've set up everything now, and I'm able to get a louder volume, not a whole lot louder, but I'm able to get a louder volume now before it breaks up, which is great news for this amp. I also want to say that I've dialed back yet again that bleed off resistor that runs through this 330 here. I've dropped it from 12 to 8K. And the reason why I did that is just because there was so much more room to break this amp up, to bring it into distortion at 8. And I figured if you could bring it to distortion at 8, there's no reason for 9, 10, and 11. So the wife has briefly tested the amp and confirmed the improvements since last time. I'm going to do a couple of things here so we don't have all the spaghetti anymore. I'm going to get this filter cap in here. I'm going to go with the 200 because I can. I got a lot of them. I have a unique position with a lot of room to work, so I'm just going to get it in there. I'm going to show you how I'm going to do it. And then I'm going to move on to a couple of other tasks to clean this up. And we're going to start closing this up because I want to get this tested hopefully tomorrow down at the music store. So let's get started. I reused another piece from the back of this old transformer tap and put it here on the edge of this capacitor. This will be a ground for the 200 microfarad filter cap I'm about to install. I think before I do the final installation, I want to see what the ripple difference is between 80 and 200. Most who know that when you hit the sweet spot there's a sharp roll off and diminishing returns, and there may be absolutely no difference between 80 and 200. I start off big when I'm working on this stuff because I don't want to be bothered, so I just slap it in there with this solid state rectifier. It doesn't matter. But let's see. Let's throw 80 in, let's throw 200 in and see if there's a difference worth even engaging in this, because the 80 is notably smaller. So here is a measurement of the 200 microfarad capacitor. We're seeing 2.5 gradicules as the measurement. And now I'm going to move over to the 80 microfarad. We're going to see what we get. Yeah, with the 80, it's not looking as good. It is insufficient. So we're still seeing a benefit from the 200. I wonder what we would get with the 80 and the 200. Let's measure that. Interesting, there's the 80 and the 200. What would happen if we went for broke and did the 200 and the 200 together? By the way, people have to be aware of what I'm looking at. I'm looking at the AC component, or the ripple in the DC. So this is not terrible stuff. This is like 130, 140 volts of DC showing right here in this specific instance. I want to make sure I'm pointed to a specific instance, so I'll adjust for it. Right. So 140 volts of DC with 0.4 volts of ripple in it is what it's showing. So not terrible considering all the flaws of the design of this thing, with everything all up on itself and the limited working environment. So what I'm just doing is looking at diminishing returns here. I think we're okay with the 200 microfarad. We're going to go with that. We're not going to get too deep into this, okay? This was just a quick check. I just didn't want anybody to be confused as to what we're seeing here. If you want to see what this really looks like what we're really looking at, I'd have to go to the times 10. This is the signal. This is the pure, like almost pure, at least from this scale. I'm from the Heathkit, I could get more, but this is the DC that we're seeing. It looks nice. So all the extra cables are now gone. I've added the capacitor in, sort of in a lean and rest position here, connected to ground on this side. Comes around here because I got the room for it, and connects in right here. So that's the filtering for the first connection off of the diode. That's done. I got the second resistor comes in down here, and that is what limits that signal coming into the beam power tube to stop the amplifier and speaker from exploding. Sort of my limiting resistor right there. Finally, I want to add in the capacitor across the line, which I'm going to do up here as well, and it will connect to the very same post that I've added. And then, because I know people are going to complain if I don't do it, the coupling capacitor to the beam power tube, which doesn't match what is in the Gibson schematic. I'm going to do that now. Not sure what benefit it'll have, but staying true to form, I've removed the 0.01 and replaced it with the 0.022 coupling capacitor. To say that to the best of my ability, I conform to the Gibson schematic wherever possible. And there it is, the final cap that ties across mains right here is installed. I think we got it all. I'm going to plug this magic eye tube in. I'm going to stage this whole thing set up and facing forward. You'd be surprised. Facing it forward also means lower volume, which means less distortion too. Something to think about. So now we're facing forward. We'll turn the volume all the way up. Nothing in the jack. And it's dead quiet. You can hear a little hiss, full tilt. We'll plug in the guitar now. Another added benefit is obviously now that the case is closed, more sound is reflected back, so you get more volume without having to crank this up, further increasing the sound before you hit distortion, which is pretty cool, and it's getting a good sound out of it. I mean, I've been playing with it. I'm not going to sit here and bore everybody playing with it on this recording forever. We'll have something special planned for that event. What I would like to do, however, is take off this case and see what the harmonic distortion is based on the maximum power output. I know that this beam power tube, I may not have mentioned it, this is only good for just over 1 watt of power. That's the max power production of this thing. You can't get it that loud because that's all it's designed to produce. It's not a guitar amp tube. I mean, I could, you know, put in something like a EL34 or 6V6 or something like that, but I don't have the power supply to support something like that. This is supposed to be a little amplifier, a little guitar amplifier that fits in a signal tracer box that has, you know, just a 1 watt or 1.5 watt output. That's exactly what it's supposed to be. And with that, a small speaker, and it's not very loud, or it breaks up with distortion very easily. So it's good enough for my liking. So we're not going to modify it. What we're going to do is we're going to test it out, run it through its paces, and see what we got. So the boss lady is providing me limousine service to Cornerstone Music, where I'll be presenting the amplifier for testing. I'm nervous. I don't know what they're gonna make of it. What do you think? She's not gonna talk at all while the record button's on, so she just made the I don't know face.
Try this thing out. Mr. Dorton.
What's going on? This diameter of the copper, the extra step, I can really do. Right. But
So cool.
At the end of the day, it's only a 1.5 watt amplifier. Left side is volume on top, right side is tone.
81.
The on-off switch is tone. That's the only two controls.
That's a bit too much.
Yeah. It starts breaking up around 70 completely. you think?
If you're looking for some dirt, there it is.
It's only 1.5 watts.
Do you use 12AX7 as a power tube?
No. 12AX7 is the preamp. It's a beam. There's a beam power tube. That's actually the output. That's the original tubes that are complement that's in there.
Oh, okay.
Just rewired very much like the Gibsonette.
Yeah.
The old GA8T. This is how this amp is wired now.
It's wild.
Arrow, get through no season, and then next year. So, yeah.